Okay, before understanding recursion, first of all, we need to understand how a function works. Suppose if you are calling a function, then what is the process? How the function are going to be work? So the working flow, first of all, we need to understand. So just have a look on my screen. So please observe the code. So here you can see we have two functions. One is main function, another function name is fun, right? So in this case, main function is calling the fun function. So here, how this function execution is going to start. So as you know, once we start our program, then the program execution is going to start from the main function. So inside the main function, this statement, first statement is going to be executed. Then second statement is going to be executed. Then third statement is going to be executed. See, once the third statement execute, so it is not going to immediately execute the fourth and fifth statement, right? So when the third statement, that means this function called execute, so the control will move from this location to the definition of this function. That means these two statements are not executed until this function call complete. So from here, it will move to this location. So in this location, it will execute the statement 1, it will execute statement 2, it is execute statement 3. Once this function execution complete, so from here, the control will move to the location inside the main function from where we call the fun function. Then control will come to this location. If there are any other operations available in this function call, that will be executed, right? Once the function, any other operation, if there is once completed, then it is going to execute the statement 4 and statement 5, and then it will complete the program execution. Is that clear?
Yes, sir.
Yes, sir.
Okay. Yeah. So here I am saying one important term. If there are any other operations in this statement 3 that will be going to execute, what do you mean by any other operations? Please observe, right? So here you can see here the same example I have written here, but in this case I am writing +2. I am storing the result inside this result variable, right? So the same process, statement 1 execute, statement 2 execute. When statement 3 is executed, so from this location it will call the function, this function body is going to be executed. So statement 1 2 3 is executed, then it will return the value, right? So it will return the value to this statement, and once it return the value to this location, then any other operation. What do you mean by any other operation? Means here this addition and this assignment are nothing but any other operation. So those any other operation is only going to be executed once this function call completes. Once this function executes and completed, and once it return the value, then only going to be perform this addition operation. For example, suppose I am passing 10. 10 into 10 means what? It will return 100, right? This function call will return 100. 100 plus 2 is going to be done once this function return the data 100. As long as it is not returning the data, you cannot perform this, because to perform some addition operation, we need some value. But this is not a value, this is a function call. So this is, we are going to get the value once this function call complete. Once this function execution completes, then only it will return the data. Once it return the data, then on the return data, we are going to perform the addition operation. And whatever the result, we are going to store in the result variable. Once this statement execution completed, the statement 4th and the statement 5th is going to be executed. So in this case, any other operation means this addition and this equal assignment are the any other operation, and which is going to be performed once or after the function call completes. Is that clear? Yes or no?
Yes, sir.
Okay. To understand recursion, we need to understand some concept, right? So please have a look at this code. So you can see, okay. So you can see I have created one function called main, right? This is my main function. From the main function, I'm calling function 1. From function 1, I'm calling function 2. From function 2, I'm calling function 3. Right? From function 3, I'm calling function 4. And function 4, I'm not calling. So in this case, how the program is going to be executed? Program execution will start from here. Once it start execution, this main method going to be executed. So program execution started from main method. Then it will call the function one, but it will wait until function one call completes. Yes or no? Once function one call completes, then it is going to execute the rest statement. So from this location, the control comes to this one. So in this case, first this statement is going to be executed. Then it is going to call function two. But this is again, this function was not going to be completed because in order to complete this function call, this function needs to be completed, right? So from this location, the control comes to this location. Here function 2 is started, then it is calling function 3. This statement is not going to be completed. It is completed once the function return, right? So this location, it will move to this location. So from here, this statement is going to be executed. This statement is going to be executed, but this statement is not going to be executed, right? When this statement is going to be executed, when this function called end. So from this location, the control comes to this location. Here, this statement executed, this statement executed. Once this statement executed, the control come back to function 4 call. Right? Once it comes back to this call, then this statement is going to be executed. Once this statement executed, from here it is coming to this place. Right? And then this statement is going to be executed. So in the same way, it will come once the function one call completes, then it will come to this place and it will execute this statement. So here you need to observe. So main method execution started first, but main method is going to be ended the last one. First main started one, function 2, function 3, function 4 started. They are not ended. Once function 4 complete, then the control come back to function 3. Once function 3 ended, the control come back to function 2. Once function 2 ended, the control come back to function 1. Once function 1 ended, the control come back to the main method, right? So this is important to understand if you want to understand the recursion. So in this case, we have calling the different function, fun1, fun2, fun3, fun4. Instead of calling this different function, if I'm calling each function, right, like this, right? Instead of calling this, what I'm doing, I'm just calling like this. Right? So instead of calling a different function, I'm writing this. So this is nothing but your recursion. So in this case, you can see program execution started from main method. From main method, we are calling one function. So in the case of recursive function, first of all, you need to call the recursive function, right? Once you call the recursive function is going to be executed. It's going to call itself again and again. See, in this case, this function 1 of 3, this is nothing but a recursive function. So here it is calling again and again, right? So just see. So what I'm doing, so I'm just printing the n value, right? $n value. Please observe. Okay, so for better understanding, what I can do is I can also type the same thing. Okay. Please observe. So the fun1 function started how many times? With the value 4, with the value 3, with the value 2, with the value 1, with the value 0, right? That means we are calling the fun function. This first call is from the main method, but itself it is calling 4 times, right? But see, this function called 4 times, but the started function 1 started with the value 4, fun1 started with the value 3, 2, 1, 0. But see, ended is going to be from the value 0, right? Once the value 0, it is ended. Once the value 1, it is ended. So in the same way, the previous example I have shown you, the same way the recursion function is going to be work, right? So the number of times you call the recursive function, it is going to be ended the same number of time. It is not like that the execution is going to happen only once. Calling means it should be end, right? So understand. So first it will call this function with the n value 4, right? Then it will print this statement. Then it will check n is greater than 0. Yes, condition satisfied. Then it is calling the function 1 function with the n value 3, right? This statement not yet executed, right? Because as long as this function call not completed, this statement is not going to be executed. See, function 1 again started with the n value 3. So it will check, yes, n value is 3 greater than 0. Yes, greater than 0. So it will call again with the function 1 with the value 2. Again, it will call the function 1 with the value 1. Again, it is going to call with the value 0. See, when we call the function 1 with 0, it will print function 1 started with the value 0. This statement is going to satisfy or not with the value and value 0. This is not going to be satisfied because 0 is not greater than 0. So in that case, this function 1 ended statement will execute. See, function 1 ended. So once function 1 ended, so it will come back to the previous call. So previous call means what? Function 1 call. So see, function 1 ended. If once function 1 ended, so who is calling function 1? Function 2 is calling function 1. Function 2 in the sense function 1 of 2 is calling function 1. So in the same way, it is going to be executed. I know there are many questions related to this. You cannot understand recursion with this explanation. To understand recursion, we need to understand the tracing tree, right? Let's see how we are going to evaluate the tracing tree. But for now, you have to remember recursion means we are calling the same function. If we are calling the function, as long as the function call not completed, as long as one function execution is not completed, it will not execute the remaining statement. With this, keep in mind, let us proceed. So what is recursion? So whenever a function call itself, it is called recursion, or we can say that recursion is a process in which a function call itself repeatedly until some condition has been satisfied. Give me a minute. See, so as long as the condition satisfied, the function will call itself again and again. That means it is similar to a loop. In loop, as long as the loop condition satisfied, the loop body is going to be executed, right? In the same manner, as long as the condition satisfied, the function will call itself. In order to, if you want to solve a problem recursively, two conditions must be satisfied. First condition, what is the problem must be written in a recursive manner. Recursive manner means you have to write the code in a manner so that it will call itself again and again. The second problem statement is that it should have a stopping condition, right? If you do not provide any condition, then it is going to be an infinite loop. For example, in this case, what is the stopping condition? The stopping condition is that when the n value becomes 0, just stop the loop, just stop the recursive call. But if I remove the recursive, if I remove the stopping condition, then what will happen? So it is going to be a infinite loop, infinite recursion. See, this is going to be executed again and again. So it is going to be an infinite. So two conditions must be there. One is the function should have written in a manner, it should call itself, that is recursive function. That means the function calling statement should be within the function. And the second statement, there should be stopping condition. You should have write some condition to stop the recursive function call like this. So two conditions should be there, recursive form and stopping condition, right? The most important point that we need to remember is that if a recursive function contains any local variable, a different set of local variable will be created during each function call, right? So in this case, I'm printing the n value. See, so the n value is 43210. That means for each call, for each function call, when function 1 is started, one variable n is allocated inside the memory with the value 4. When second time we are calling with the value 3, another variable of another n variable will be created inside the memory location with the variable 3, right? If again I am calling with the value 2 means n is again created inside the memory with the value 3. That means if you are having a local variable, so in this case, this is my local variable. So inside the function, you can have other local variables as well. For example, in this case, I can declare also integer y, right? So this is also a local variable. This is also a local variable. So for each recursive function call, these local variables are going to be created. If the recursive function call itself 10 times, that means in the memory, these local variables are going to be created for 10 times. You have to remember that. Is that clear?
Yes, sir.
Okay. So this is the general form of a recursive function. So you can have some local parameter or variables. You can have this function name, return type. You should have some base condition to be checked before calling the function call. This is base condition, and this is your problem statement. That is recursive function. Here we are calling the function within the same function, right? This is fun function, and we are calling the fun function within the fun function, right? This is recursive function call. And before this function call, you may have some statement, and after the function call, you may have some statement. So these statements are going to be executed before the function call, and these statements are going to be executed after the function call. Is that clear?
Yes, sir.
Okay. So one more point that you need to remember is that inside a recursive function, you can see that there is a base condition. That means there must be some base condition. See, this is the base condition. Without, if you do not write any base condition, then what will happen? It is going to be a infinite recursive function. There is no ending. It will call again and again. And as long as there is some memory, and as long as the memory overflow is not there, stack overflow is not there, so it is going to execute again and again. So base condition is important. Without base condition, if you are trying to write the function, then it is going to be an infinite function, right? Now, let us see how exactly the recursive function works. Okay, please observe this code. See, so here from the main method, I am calling this function. So first of all, you may you just tell me this is a recursive function call or not, because we are calling the same function with the reduced value of n by 1, right? And here this is the base condition. Before calling the recursive function, it will check whether the condition is satisfied or not. So if I execute this program, can anybody tell me what will be the output?
3, 2, 1.
3, 2, 1. Exactly. So when you execute this program, it will give you the output 3, 2, 1. See, 3, 2, 1. Now we need to understand. This is a small piece of code. I have written only the value n. This is small code. So you understand this is going to be give me the output 3, 2, 1. But how this function is going to be executed? What is the recursion tree of this function? That we need to understand. If you want to solve any bigger problem using recursion, then you should know what is a recursion tree, how this recursion tree is going to be evaluated. That is the most important point, or that is the most important thing that you need to understand if you are going to work with recursion. Let's see. A recursive function is traced in the form of a tree. So let us start tracing the tree. When the condition is true inside a function, there are two statements to be executed. In the first statement, it will print n value. In the second statement, it will call itself, and this has to be done only when n is greater than 0, right? So you can see inside this function call, we have two statements, right? So this is the base condition. As long as the condition is true, it is going to execute two statements. This is my first statement, right? This is your first statement, which is nothing but a printing statement, and the second statement is nothing but your recursive call. So this is the recursive call. So as long as the condition is satisfied, these two statements are going to be executed. Now, how they are going to execute? First, okay, please observe this image. So from the main method, we call this fun1 function. So when we call this fun1 function, what will be the n value?
3.
3. And is this condition satisfied?
Yes.
So if this condition is satisfied, what it will first print?
3.
It will print
3.
3. And after printing 3, it will make a function call with what value?
2.
Right. So it will make a function value with 2. So this is what I have given here. So there are two statements or two steps. First step, it will print the n value. N value is printed here 3. Yes or no? Second, it will call this function again with what value? With the reduced value of n by 1, that is function 1/3. So, okay, from the main function, we are calling one function by passing x value, that is 3. So the first time the variable n has got the value 3 and 3 is greater than 0, and hence the condition becomes true. So the first step, that is to print, that is it will print 3, and the second step is to call itself again f1 for 3 minus 1, that is your function of 3 has not completed, right? So what the point that you need to remember is, so here first call is what? First call is a function of 3, right? So when the function 3 is called, it will check this condition satisfied. So it will print this value is printed. After printing this value, this function call is done. Is this function completed?
For f of 3, sir.
No, I'm asking. So whenever from main method we are calling this function, so with the value 3. So once you pass the value 3, this statement, this condition satisfied. Once this condition satisfied, this statement is executed. Once this statement is executed, this method is called. So this function is called means the previous function call, which function 3 is not yet completed.
It's not completed. Yeah. Yes, sir.
So when function 2 complete, right, when the function this function 2 call, what we are doing right now, once that function returns, then only this function is going to be completed, right? For example, suppose I'm writing this statement as well, right? So in this case, first it will print 3 to 1, then it will print 1 to 3 in this case. See, 3 to 1 and 1 to 3. That means this statement is only going to be executed once this function call complete. You need to remember that. That we will see also. So in this case, so when function 1 of 3 call, so first step, this 3 will be printed. Second step, it will make itself a call with the reduced value of n by 1, that is fun1 of 2. Now, so this is function 1 call, but remember, function 1 call has not yet completed. See, function 1 not completed, but it is calling function 1 of 2, right? So what will happen in this case? Already we have printed 3, and this step we have discussed. So again, when function 1 of 2 is called, so what will happen? So 2 is greater than 0. Yes, condition satisfied. Print the value of 2. So output will be printed here. Then it will call what? Again, it will call what? Now function 1 of 1. Is that clear? See, the same thing I have written here. Function 1 of 1, that is n minus 1, that is 2 minus 1. So that means what? Now here also function 2 call not yet completed. Function 1 of 2 call yet not completed, but it is calling function 1 of 1, right? Is that clear?
So, sir, it's like that function 1 of 1 is inside function 1 of 2, and that is inside function
exactly.
1 of 3.
Exactly. The first example I have shown you. Okay, let me take the code so that you will understand better. Control C. Create another class file. You know how to add class file? Right click on your project, add, and there is new item, right? So there is a option class, but you can search class. You can give any name to your class. So I'm giving the test. I'm adding this one, right? See, you can see. Okay. So see, from here we are calling this method, right? So from main method we are calling fun1, from fun1 we are calling fun2, from fun2 we are calling fun3, from fun3 we are calling fun4, right? So this is the same thing. So from here we are calling another method. From inside body we are calling another method. This method call is going to be completed when this function call return. This method call is going to be completed when this function 3 execution complete. So function 3 execution complete when function 4 execution complete, right? So from here it will execute. So that means first the last method which is called in the sequence once complete, it will return to its previous call. From previous to its previous one. From this one to it will return to its previous one. And when function 1 complete, it will come back to the main, right? The same thing is also here. So the same thing is also here. So here we are calling different function, and here we are calling the same function, but with a different value that you have to remember. Function 1 of a 3. Consider this is function 3, right?
Yes, sir.
Okay, so function 3 calling function 2, right? So consider this is function 1, 3. So let's say this is function 13. Function 13 calling function 12, right? And before calling this function, it has to print the value 3 because that statement we have written before the function call.
Yes, sir.
Okay, so print, and then it will call this function, right? And when this function 1 of 2 or as per your understanding function 12 call, so it will come, it will call the fun1 function with the value 2. So 2 is coming to this n variable. 2 is greater than 0 condition satisfied. It will print this statement. So 2 is printed here. 2 is printed here. Once it printed 2, so it will call the same function with the reduced value of n. So current value of n is 2. 2 minus 1 is 1. So it will call fun1 function with the value 1. Is that clear?
Yes, sir.
Okay. So fun1 of 1, right? So here it will first fun1 of 1. Let's debug the same. Fun1 of 1. So here n is 1. 1 is greater than 0 condition satisfied. So it will print what? It will print 1. After printing 1, what it will do? It will check the reduced, it will again call the function 1 with the reduced value of 1. So 1 minus 1, what it will become? Function 1 of 0. So it is calling function 1 of 0 or not after printing 1. So now the function 1 of 0. So in this case, when we call function 1 of 0, so does it going to do anything?
No.
No. So function 1 of 0 is not going to do anything. Then what will happen? So from this statement, right? From this statement, it will return to its previous call. Which one is the previous call of function 1 of 0? Function 1 of 1, right? So it will come to this place and it will check, is there any, and here the current n value is 1. Is there any statement to be printed? No, there is no statement. So the function call is completed. So it will come back to its previous call. Previous call is means function 1 of 2. Is there any statement to be printed? No. So it will come back to its previous statement. So like this, it will come back to the main function, right? To understand this better, we have to see another example, right? Okay. So in the previous statement, this is the same example as the previous one, but in this case, we have written the statement after the
Printing after the function call we are.
Yeah. So can anybody tell me if I run this application, what will be the output?
1, 2, 3.
Sorry?
Sir, 1, 2, 3.
Yes, 1, 2, 3. Why? Because the last function call once completed, then it will call to its previous call. So let's create this example. Let's see. Compare this example. So the only difference is that in example 1, we have written the console statement first. In example 2, we have written the console statement after the recursive function call. This is the difference. Okay. So now let us trace this program. So in this program, when the function call is happened, so first it will execute this function with the n value what? With the n value 3. So 3 is greater than 0, yes, condition satisfied. So it will call the function 2 with the value 2. It is not printing this statement. So please observe. So the statement is not executed. The second statement, this statement is not executed, but it is calling this function. Is that clear? Function 2
Yes,
of
sir.
3 calling function 2 up to, but it is not executing the remaining statement. This statement is not yet executed. It is just calling function 2 up to, right? So when function 2 up to call comes to this place, so it is taking 2 is greater than 0. Yes, it is greater than 0. So it is calling itself again with the value 1, because 2 minus 1 equals to 1, and this statement is not executed.
Yes.
Right? So you can see function 2 up to calling function 2 up 1, but the remaining statement is not executed. Right? So when function 2 up 1 comes, it will check 1 is greater than 0. Yes, condition satisfied. So call again with the value 0. So 1 minus 1, 0. So function 2 up 1 is 0. Yes or no?
Yes,
So
sir.
function 2 of 1 calling function 2 of 0, and this statement is not executed, right? So
Yes.
when the function 2 of 0 calls comes, so is anything to do when function 0 is coming? When
No.
n value is 0, we do not have to do anything. That means the function 0 execution is completed. Once completed, it will come back to the previous function call and it will execute the remaining statement, right? So for this function 0, who is the previous statement?
1.
Function. So this function does not do anything. That means this function will return to its previous function call. Na? What
Yes,
is the who is the previous function call?
1.
Function 2 of 1. So function 2 of 1, the remaining statement will be executed. Yes or no?
Yes, sir.
Okay. See, the remaining statement will executed, and for this function, what is the n value? N value is 1.
Yes, sir.
Right? So it will print what it will print? It will print 1. After printing 1, it will again, after printing 1, the method call completes, it will come back to its previous call. So once this remaining statement executed by function 2 of 1, so it will comes to its previous function call. Who is its previous function call?
Function 2 of 2.
Right? So function 2 of 2 is going to be executed or not?
Yes, sir.
So once function 2 of 2 completes its execution, that is, once it prints the value 2, it will come back to its previous function call. Who is its previous function call?
Function 2 of 3.
Okay. So function 2 of 3 means what is the n value?
N value is 3.
So this, what the parameter we are taking, this is nothing but n value. So it will print the value 3. Once the function 2 of 3 completes its execution, then it will come back to the main method. Yes or no?
Yes, sir. Sir, so we can say that like in a recursive call, first the flow will go according to the condition, and then all the functions will return in reverse order.
Right. So once the last function completes, say the same thing. So in this case, we are calling the manner. We are calling the same
Yeah,
manner. But once this function completes, then it will come back to its previous function. Once this one complete, it will come back to its previous function. Right? Once this
Yeah.
one complete, then it will come back to this main function.
So sir, like it will be like always be like if it's going like 3 to 1, then it will always return 1 to 3. Whether
Exactly.
if there is some
Exactly.
thing like something to print or some statements are there, then it will execute. But if there is no, then also like it will go in reverse order for sure.
Sure.
Yeah.
Okay.
Okay.
Okay. So for better understand what I'm doing, I'm just writing the same code, right? So you will see this statement is executed first, then this function call, right?
Yeah.
And then this statement is going to be executed once this function call completes, right? Let's debug this program. Okay. So we are having some main method here. So we cannot debug the program, so we need to remove that. See, the program execution start from the main method, right? So I'm calling function 2 of x. So what is the current n value? You can see it is the current value n is 3, right?
Yes, sir.
So as per our understanding, this statement should be executed first.
Yes, sir.
Yes or no? So
Yes,
once this statement executes, it will print what value in the console?
3, sir.
3. Please observe the output. So 3 is printed.
Yes, sir.
3 is printed. After
Yes, sir.
printing 3, it will call itself. So
Yes,
when this statement is executed, this statement is not going to be executed. Line number 19 will not executed. It will again come to this function call with the reduced value of n. Okay, please observe. Come to
yes,
this statement now. N value
yes,
is
sir.
2. So now it will check 2 is greater than 0. Yes, condition satisfied. It will print the n value 2. So now you can see 3, 2, 2 is printed, right? Then again it is calling itself. Now n value is 1, right? So you will see 1 is greater than 0, condition satisfied. Again it will print the value 1, 1 is printed. Once 1 is printed, then it will execute this function statement, right? So
Yes,
when
sir.
it is executed, it will call itself with the n value 0. But now this condition is not satisfied. Is this condition satisfied? No,
No, sir.
it will not satisfy. So it will come back to its previous call. So previous call means one. Now function 2 of 1. See,
Yes, sir.
so it is coming to this place. Now if you check one n value is 1 or not. So
Yes, sir.
once 1, so it will execute the next statement. So you
Yes,
will
sir.
see 3, 2, 1, 1. Now
Yes,
it will now this method execution complete. So it will come back to its previous call. So who
yes,
call
sir.
this now? N where n value is 2. Right? See, come to this place. You can see n value is 2. So 2 is going to be printed, and the same way again it will come to this place, and you will see n value is 3. Right? So this is the last call, and this n value 3 is printed. After printing this n value, it will come to this function statement from
Yes,
where
sir.
we call this. See, come to this place, execute. So you will get the output like 3 to 1, 1, 2, 3. Is that clear, Pratik? Yes. So this is how a recursion is going to work. Because see, writing the factorial of a number is not that important if you don't understand how the function call and how the recursive function is evaluated. This is on the understanding of recursive function is much more important than writing the factorial of a number program. Now, as you know, in academic or everywhere you learn, they will explain you that uh, when a function call itself, it is called recursive function, and the example is factorial of a number, right? So they just give you the example, but I don't think whether they are showing you the tracing tree how the function is going to be evaluated. Now,
Hello.
yeah.
Yeah, sir. Actually, like earlier, it was like we are clear with like 3 to 1, but like we were not clear with it's like reverse order will also fall in that case.
Right, that is what I'm saying. Na?
Yeah.
You only know you once you execute it will print like this. But
Yes.
how the function call is happening, right? That is
Yeah.
the important thing,
Yes, sir.
right? So now see factorial of a number, you know this program very well, right? So you know number into factorial number minus 1. But what is happening when this equal when this statement is going to be executed? That is the important thing that you need to understand. Now, so I'm writing this program, and once I'm providing 5. So once I execute this program, I will get the result as 120. Right? Factorial of 5 is 120. But getting 120 is not important. Understanding how we are getting 120 is the important thing. Right or not? So now let's trace this application so that you will understand this better. So first of all, factorial of 5 will be called. So first this call will come where n value is 5. Yes or no?
Yes, sir.
So 5 means this statement is not going to be executed. Yes or no? The else part is going to be executed,
Yes,
right?
sir.
So in this case, number is 5. Then it is calling itself with what value?
4, sir.
4. So this is not executed. See, in this case, this expression evaluation is not done, right?
Yes,
Why
yes,
it
sir.
is not done? Because once this method return the data, then only this expression is going to be evaluated. Na?
Yes, sir.
So in this case, that expression evaluation not written, that means not executed, right? So from 5, it is calling factorial of 4. So not executed. From factorial of 4, it is calling factorial of 3. From 3, it is calling factorial of 2. And from 2, it is calling factorial of 1. But when I'm calling the value, when I'm calling the factorial by passing the value 1, so in that case, this condition is satisfied. So what it will return? It will return me 1. Yes or no?
Yes, sir.
Okay. Now observe. So it is returning 1. So it is return 1 to whom? So it is return 1 to whom? So factorial of 1
function.
return 1 to whom? To factorial of 2 only. Because we are calling this factorial of 1 when
Yeah,
n
sir.
value is 2. Yes or no?
Yes, sir.
So factorial of 1 will return 1 to whom? Factorial of
Factorial of 2.
2. So in factorial of 2, what is the n value?
2, sir.
So factorial number minus 1, that is factorial 1 returns 1. So number into factorial in number minus 1 means what? 2 into 1. So it will return 2 to whom? So the expression evaluation is done. So in this case, what will be the output or what will be the result?
2, sir.
2. So it will return 2 to whom? To its previous function call or not?
Yes, sir.
What is its previous function call? Previous function call is factorial of 3. So in factorial of 3, so number is 3 and this factorial of 2 return 2. So 3 into 2 equals to
6.
6. So this 6 will return to its previous call. So the previous call is factorial of 4. Factorial of 4 means here n is 4. So n is 4 and this factorial of 3 return me 6. So 4 into 6, what will be it? 24. And this 24 is returned to whom? Factorial of 5, right? In factorial of 5, n is 5 and factorial of 4 return me 24. So 5 into 24 equals to 120 and this 120 will return to the main function. Is that clear?
Yes, sir.
Right. If anybody having any doubt, then please ask me because I am getting response from a single version.
It's fine, sir.
Okay, fine. See, so whenever you are working with the recursion, it is very slow due to stack overlapping because each time the function call will happen. So in the method stack area, a new stack is created where it will create the variable. So stack overlapping is happening that I will show you practically. And the recursive program creates stack overflow. That means is suppose in this case I'm passing 5 instead of 5. If I'm passing 500, then 500 number of times the local variables are going to be created. So there might be chance stack overflow is happening, right? The create infinite loop, right? If you have not provided any condition, if you have not write this if else condition, then it is like a infinite loop. For example, in this case, if I'm writing like this, so you will see that it is going to be an infinite loop. So process is terminated due to stack overflow. Why it is stack overflow? Because we have written 500, so it's a very big number. So it cannot create that many number of variables. So stack overflow is there. So instead of 5, I'm just passing 5. I'm just printing the console dot write line, and I'm printing the number only. I'm just making this as a point. So in this case, you will see it is going to be a infinite loop. What happened? Oh, I have not written this call. And I need to call this function.
Calling function.
Yes. Function call is there. So in this case, it is going to be an infinite loop. See, this is going to be infinite loop. So you have infinite loop, right? And you have stack overflow. Stack overflow, yeah, suppose I'm writing this statement, and if I'm writing not, and if I'm passing 500, so you will get stack overflow. Not stack overflow. Why? So sometimes you will get Stack Overflow because it is executing the function again and again. At some point of time, there is no memory in the stack, and in that time you will get the Stack Overflow exception. All right, but that is not our main objective. We need to understand how variables work in a recursive function. Okay. See, you will not get message because I don't know when we'll get the message or whether we'll get the message or not. Yeah, now you'll see process is terminated due to Stack Overflow exception. Is that clear, Pratik? Okay, fine. So we cannot give guarantee when we are getting. So as soon as the memory is not there, so we'll get Stack Overflow exception. Okay. Right. So see, in this case, we need to understand how many times the variable is going to be created. See, here I'm calling this fun function, and this is the logic we have written inside the fun function. And we need to observe this is a recursive function, right? Because we are calling the function itself. As it is a recursive function, then how many times this local variable n is going to be created, that we need to understand. As you can see in the above code, there is a function called function which take one parameter, that is n type of integer. Then if the n value is greater than 0, it will call itself with a decreased value of n. So this is one parameter n of an integer type, and if the condition is successful, if it returns true, then it is called itself with the reduced value of n. Right? So when this clause will be done, right? So when this clause will be done, so here you can see we have written some clause n, right? So this clause n will be done either calling time or returning time, right? So in the calling time, this clause operation is not going to be happen because in the calling time we do not know what is the value. So once the value, we got the value of this function call, then we can add the this n value with the return value, right? So once this function call completes, once it returns some data, with that return data, we are going to add the n value. Give me 1 minute. Right? So basically, this plus operator is going to be executed at the returning time. There are the two phases. One is calling time, another is returning time. Calling time means before calling the function, do I need to execute that? That is calling time. After calling the function, do I need to execute that? That is after returning time. So this function, this plus operator evaluation is going to be done after returning time. So once this function returns some data, with the return data, this function, this addition operation is going to be performed. This is what. So will be done. It is done at returning time, right? If the value n is 0, then it returns 0. So when the value n becomes 0, it returns 0, right? From the main function, we call the fun function passing let strings. Okay, from the main function, we pass the value 5, right? So 5 is greater than 0. Yes or no?
Yes.
So if 5 is greater than 0, then this function call will take place. That is, this function will call with the value of 4. But this plus addition will not be executed at that time. See, function 4 plus this call will be happen now. Function 4 plus n. 4 is greater than 0 and n will be filled at returning time. So once it will return, once this function call return, then at that time this n value will be added, right? So function 4 it will call function 3, and this n will be added at the returning time, right? And function from function 3, fun of 3, it will call fun of 2 plus n. This n will be added at returning time. Fun of 2, it will call fun of 1 plus n. This plus n will be written at returning time, and 1 is greater than 0, So condition satisfied. So this fun of 0 plus n will be done. So fun of 0 plus n. So when this fun of 0 call happened, right? Fun of 0. So this condition satisfy or false?
False.
False.
False means what it will return,
0.
0.
right? So fun of, so in this case it will return 0. So please observe this. So fun of 0 will return 0, right? So fun of 0 will return 0 to whom?
Fun of 1.
Fun of 1.
So fun of 1. So in this statement, what is the n value? What is the n value? N value is nothing but this value, na? Yes or no?
Yes, sir.
So what is the n value? It is showing fun of 1 means this 1 is nothing but the current n value, right? So 0 plus 1. So fun of 0, that means this statement will return me 0 plus I need to add 1. So what will happen? What will be the result?
1.
1. So this 1 will return to whom?
Fun of 2.
So fun of 2. So fun of 2, this first 1 is nothing but your fun of 2 plus 2 means this 2 is nothing but your n value. So fun of 2 means 1 plus n equals to 2. So what it will becomes?
3.
3. So this 3 will return to whom?
Fun of 3.
So fun of 3 means 3 plus n. N is 3. So 3 plus 3 what will become?
6.
6. This 6 will return to whom?
Fun of 4.
So fun of 4 means 6 plus n. What is the n value?
4.
4. 6 plus 4 what it will become?
10.
10. This 10 will return to whom?
Fun of 5.
So 10 plus 5. So here, so what is the value of n? N is 5. So 10 plus 5 what it will become?
15.
And this 15 will return to whom? Main method, na?
Yes.
Main method.
So when you execute this program, as per our understanding, it should return us 15. It is returning 15 or not?
Yes.
So this is how you need to trace the program, right? So this is how you need to trace the recursive program. And if you do not know how this evaluation is done, then it is very difficult for you to understand the recursion, right? So in factorial number, you know, you will get the output. But in this case, if I, without executing the statement line by line, if I ask you what would be the output, then see, in this case, if I multiply this number with the n multiplication, what will be the output? Can anybody tell me?
0.
0, because the fun of a 0 will return 0, na? Once we multiply any value with 0, always it is going to be 0. So
0.
in this case, the output is going to be 0. See, 0. That is what you need to understand, how exactly the expression evaluation and the tracing tree of recursive function going to work, right? See, in this case, so in this case, when I pass n value as, so in this case, we need to understand the memory architecture. First of all, when the program execution is start, okay, let's debug this application. Okay, so when the main method is start, okay, please observe one variable is created, number with the value 5. So in this case, so here a is 5. Okay, so do one thing. This number, let's give this number as a. Let's give this number as a. Right? Give me 1 minute. So in this case, when the program execution start, right, inside the main memory of inside the main memory there is a space called stack. Inside stack, for the main method record area will be created, and inside that record area it will create a variable a and it will store the value 5. So a is created, and this is the code section. The machine code will be loaded inside the code section. There is section called heap and there is section called stack, right? So inside the stack section, main method area will be created. So it will create this variable a and it will store the value 5. So a is created with the value 5. Then it will call this function. So another local variable will be created with the value 5. So n is created with the value 5. Again executed. Again n is created with the value 4. N is created with the value 4. Right? Again n is created with the value 3. N is created with the value 3. Again n is created with the value 2. N is created with the value 2. Again n is created with the value 1. Again n is created with the value 0. That means the number of time you will execute, the number of time your recursive function is executed, the local variables are created separately, right? That you need to remember. And all these variables are created inside the stack memory. And whenever there is a memory issue, right, infinite case, infinite loop, each time the variable will be created, and at some point of time you will see that there are no memory. So in that case you will get stack overflow execution. Is that clear?
Yes.
Okay. So now see, so in this case, if I'm passing n value as 5, so 5 n value as 5 means n is created 1, 2, 3, 4, 5, 6 times. If I pass n value as 10, so it is going to be created for 11 times. Yes or no? If I'm passing n value as 100, then it is going to be created for 101 times. Yes or no? That means each time we will execute, each time the function will call, it will create and it will execute the body, and once it execute or create the I mean, what you need to understand, each time a function call means it's a new call, it's a fresh call, so that the variables are going to be created each time you call the method. So if you are calling the method 5 times, that means the variable will be created 5 times, right? Now, so instead of writing this for loop, you can easily convert that to instead of writing this recursive function call, you can convert that to a for loop. So now please observe this code. So this is the function call, and now I'm writing the same thing using a for loop. See, so this is integer result, and I'm writing I equals to 1, I less than equals to n, I plus plus. Result equals to result plus I, and I'm writing the result. This for loop is nothing but it is the equivalent of this recursive function call. What this recursive function do, this for loop exactly does the same, right? Now, instead of a font, if I'm passing font 1, I will get the same output. See, 15 I'm getting. Then you will ask me, sir, what is the difference between these two, right? So in this case, the loop is going to be executed 5 or 6 times. This for loop is also going to be executed 5 or 6 times, right? There is no difference in time complexity. How much time this method is going to be taken, the same time is also going to be taken by this for loop, right? So for loop is nothing but it is equivalent, or you can reduce the complexity of you can say recursive function using a for loop. What is the advantage? Why I'm not preferring to use a recursive function call, and why I'm prefer to use this for loop? Only because of space complexity. Only because of a space complexity. What do you mean by space complexity? See, so the time, so whenever you are writing any application, you need to understand 4 things. One is time complexity, and another one is space complexity. What is time complexity? How much time the function is going to be take? That is nothing but time complexity. and that basically depends how many times the function is going to be executed or how many times the loop is going to be executed. If let's assume this execution take 1 unit of time. If I am calling this function 5 times, then it will take 5 units of time. And the same case, if I am executing this statement and say if it is taking 1 unit of time, if I am executing this for loop 5 times, means it is also going to take 5 units of time. So there is no difference in terms of time complexity. This recursive function will take 5 units of time, and this function without recursive function is also going to take 5 units of time. Then what is the difference? The difference is in terms of a space complexity. In this case, if this function is executing 5 times, means this n variable is going to be created 5 times. Yes or no? Yes or no?
Yes.
Yes. But in this case, if this loop is going to be executed for 5 times, is this n variable is going to be created 5 times?
No.
That means this n variable is going to be created only once it is going to be created. And in this case, n is going to be created depending upon the number. If I'm passing n as 100, this n variable will be created 100 times. In this case, if I'm passing n as 100, this variable is going to be created only 1 time. So this will give me, so this will take less space, less memory comparing to the recursive function. This is the reason why I always prefer to use loop instead of recursive function. And whenever you are going to work with any real kind project, you will not see any kind of a recursive function call. But understanding recursive function call is important, right? Because some of the code internally they have implemented recursion. Right, so understanding recursive function is important, but in your real-time application, you will not find any. If you are going to work with any existing project, you will not find any recursive function call, right? Or if you are going to develop any application, you will not find any recursive function call. Now, you just tell me from these two method call, which one looks better and understandable to you? The one which is without recursive function call, or one which is recursive function call? Which is easier to understand, which is easier to debug? You just tell me that.
Without recursion.
Without recursion. And in terms of time complexity, both are going to be same. Big O of n. So depending upon the n value, the number of times the loop is going to be executed or the recursive function is going to be executed. But in terms of space complexity, this recursive function call example will give you better performance than this one, because in this case the space is going it's not increasing. Only one time n is going to be created, whereas in this case the n is created n number of times. And understanding for loop is very easy as compared to recursive function, because we do not have to write that a tracing tree in the case of a for loop. Is that clear?